Let's get started. Okay, so my name is Louis Vernon. I'm a site reliability engineer at a company called Descartes Labs, based in New Mexico. I'm going to be talking to you today about getting familiar with Spinnaker and specifically the Kubernetes V2 Provider. We happen to be running on GKE. There's not much that's GKE specific. There are a couple of things. I guess I'll put it out there that this is like a kind of a user group talk, and sort of I discuss like some of our pipelines. I also wanted to mention this is my first ever technical talk as a site reliability engineer. Previously, I was a scientist. A year ago, I was a scientist at Los Alamos National Lab, and I worked on the performance optimization of scientific codes, like monolithic applications running at 2 million or more threads. Then I moved to a tech cloud-based startup, started working on the problem of microservices at tens of thousands of threads. That is definitely a harder problem. I just wanted to put that out there. Okay, so I mentioned I work for Descartes Labs. What is Descartes Labs? Descartes Labs is a tech startup in New Mexico. There aren't many of us. It's also out of Los Alamos National Lab. It was founded by a bunch of scientists, really great scientists who had some great ideas about computer vision and high-performance computer vision stuff. It's currently based in Santa Fe. It started off in Los Alamos. And our goal is to provide a platform to derive insights from petabytes of geospatial information. And ideally, the end users don't even know the scale of the underlying data they're processing. Currently, we sit about 80 employees. I think we have over 20 engineers. And the company, since I joined in the last year, has doubled in size. And that sort of is kind of relevant to what I talk about in this presentation. Oh, and that's Franny. She's like director of greetings or something like that. Okay, what does our platform look like? So Descartes Labs platform, it's primarily Python. We're using the Flask framework. We do have a number of languages. We have some Rust and we have some Go that we use in production. Rust is bolded because it's a very small amount of Rust, but it does very, very important jobs or a very important job in our platform. There's also C and C++ and various other languages out there, but most of the deployment stuff is related to applications that are Python and Flask, Python with Flask. Our platform is built almost entirely on Google Cloud Platform. Like our core platform is all in GCP. We do have small pieces on other cloud providers, like just where it makes sense, because obviously we suck in a lot of data, and sometimes our data sources are in other cloud providers. We don't have any managed infrastructure like at the hardware level. Probably like a particularly notable thing about our relationship with GCP is we have over 10 petabytes of data in GCS, and we do sort of analytics over that data. Our core platform is built in Google Kubernetes engine. It's all I've known since I joined the company. I checked Slack, and my crazy manager has been using it in production GKE since Kubernetes version 0.19, which was back in 2015. I mean, like, it was limited production use at that time, but still. We began like the migration in earnest at, just before version 1.6, so that was last year sometime. And our Spinnaker pipelines are only concerned with the infrastructure that lives on GKE. We do have some legacy infrastructure on GCE. Slowly, we're moving stuff over as the platform becomes more capable. It's kind of important to know what kind of utilization there is of our platform because we're doing continuous deployment and we want services to be healthy all the time. And so the utilization of our platform is we have some static load because we're constantly looking at real-time ingest of geospatial data and there's corresponding analytics that's performed as it's pulled in. We pull in 10 plus terabytes a day. Sometimes that's order of magnitude higher when we add a new partner or whatnot. But the vast bulk of our load is dynamic load, so that's people doing live exploration of the geospatial products, post-processed data, derived analytics, that kind of thing, or they're building and testing sort of ML/CV models. But the biggest load, very, very substantial load on our platform is when people actually are satisfied with a model and they want to run it over large scales, and that's when we hit these tens of thousands of vCPUs I mentioned in the abstract. This is a crazy drawing of our platform that a platform engineer just happened to put together for a different talk the other day. All this serves to show is We have a number of microservices that have relatively complex interdependencies, so like we have sort of a complex enough system, I think, to sort of worry about continuous deployment and service stability. The stuff at the bottom of this chart is all like our persistent storage abstractions, and there's PubSub, GCS, BigQuery, data store, Redis, Postgres. They're all GCP managed services. Well, managed to some extent, some more than others. The exception there is Elasticsearch. We have a very big, well, I think it's big Elasticsearch cluster in GKE. And I should have mentioned, for the SRE team, which is just the three of us, that's probably recently at least, it's been the biggest maintenance burden. Okay, so let's talk about growing pains. We flash back to the beginning of 2018. I was still pretty fresh-faced SRE at the time. We had a really rapidly growing engineering team. We had emerging sub-teams for the first time. We had like communication breaking down as teams were being partitioned. We had a rapidly expanding catalog of services that was being figured out. We really like how Google does things. We're trying to emulate them whenever possible. So we were consolidating we had, I think, over 100 repos at the time, and we consolidated everything into one mono repo using Bazel. Actually, I think I've got 3 colleagues at BazelCon right now. And we had several CI technologies. So different teams had put together their own, what made sense to them in terms of CI pipelines. So we had Drone.io, Circle CI, Container Builder, and Jenkins. Actually, I think Jenkins has already been deprecated by the time I started. But more importantly, we didn't have any formal continuous deployment process. One person on our company put together this kubectl bot, which basically was you could post your kubectl deploy command to a Slack channel, and it would apply it to the bot. And the only reason for that was just to have a nice audit trail. Who did what, right? Engineers had GKE privileges. We didn't have like a formal, here's best practice. This is a good deployment strategy. So we got all sorts of namespaces popping up all over the place. Hopefully people can relate to this. At the same time, the SRE team had this big push around managing complex service. Well, actually, we'd have a big push about capturing our infrastructure as code. So again, that was, we interacted with some Google Solutions engineers, and we really liked the sound of that. At the time, there was like an embarrassing amount of G-Cloud CLI stuff, but now stuff is being all captured in Terraform. So we had this like nice redeployable infrastructure through Container Builder, which executed whenever we made change to our repo. But Kubernetes manifests were like a totally different world, like the Wild West there. If they were captured at all, they were poorly captured, and they went immediately stale. People are editing the manifest like kubectl edit, or they're going in the console and changing them. So they're immediately out of date. And so we wanted an automated way to deploy Kubernetes manifest from code. And we wanted it integrated into our software development workflows. We wanted to be able to like do a PR, trigger a build, have a nice like revisioned auditable history. We wanted it to be reproducible with like versioned executions, and we wanted it to be revertible. So like either through a manual or automated procedure, we'd be able to roll back a deployment. And these 3 things kind of meant that like tagging it onto some CI process just didn't make sense, right? I think that's why we're all here. So it's mid-February. We have a conversation with a Google Solutions engineer called Vic. And Vic says, well, you guys already have all your infrastructure captured as code. And if you like that, you're going to love the Spinnaker V2 Kubernetes Provider, which at the time was just launched in alpha 1.6.0, and was like, despite the fact that we really appreciate it, it was very, very painful to use at the time. Initially, we did like an explorative effort where we were trying to manage clusters using the V1 and V2 providers, but we'd come from like a purely manifest Kubernetes world, and the V1 provider like explicitly managing resources, like having like defined load balancers, that was sort of orthogonal to the way we'd already been thinking about the problem. So V2 naturally appealed to us. And also, when you try and use them both at the same time, you end up with these confusing deployment models because, well, you can't, right? There's there's artifacts that get produced by one stage that don't make any sense to a different stage that uses the V2 provider. Just to give you some context, actually, if you don't already know like what the differences are between the two providers. So like typically, I say many Spinnaker providers, but I think it's maybe all of them apart from the V2 provider. Spinnaker explicitly manages the underlying resources involved in rollouts, rollbacks, deployment strategies, scaling, and so on. Or maybe not explicitly scaling all the time, but it can scale, right? The V1 provider, it follows that same model. So your Kubernetes cluster is sort of treated more or less like a generic cloud offering. And like I said, this was sort of orthogonal to Kubernetes declarative object management architecture. And so the V2 provider leverages Kubernetes native object management. Lets Kubernetes take care of like a rolling upgrade of a deployment. And it works very nicely with your existing manifest. Oh yeah, so before I continue, I just wanted to know, like, how many in this audience are using Kubernetes right now for the services? Okay, so that's most of you. What about using Spinnaker? It may seem like a really stupid question at this point, but I don't know. Okay, all right, not everybody. And who's using the V2 provider already for the? Okay, so there's a good number of you. Before I even talk about the deployments inside of Spinnaker, it seems like a worthwhile conversation to talk about how we deploy Spinnaker. I've already found quite a few people that like have had issues configuring Spinnaker correctly, and we built some automation around that. It's not sophisticated at all, but it's nice and reproducible. So we have a pipeline that creates a Spinnaker GKE cluster. I put the credentials are encrypted in the repo only as like a confession that I feel terrible about. But that's the model we use. So this launches a Halyard deployment. We defined a Kubernetes deployment that has Halyard in it, launches it in the cluster, and then it explicitly, at a bash level, it kubectl copies this Halyard dynamic configuration script that we have, and it executes that script on the pod, right? It doesn't sound pretty, but it works very well. And actually, it leads me to this conversation of YAMLs versus dynamic configs. So, you could, in theory, configure your Halyard pod, capture all the configuration state, and just like copy that state in, or build a pod that has that state in it, and build an image. And we actually went with that model first, in fact, what we were doing, we weren't baking it into the image, but we were putting it in GCS, and then we were using the GCS Fuse plugin to expose that config. And long story short, we've actually had more stability dynamically interacting with Halyard to generate the config, which we could, of course, do offline, have best of both worlds, then trying to persist the state. Does this hopefully make sense to everybody? There's some customization we had to do, and I don't know how much of this is necessary today, but we have to customize our gatelocal.yml because something about the Google load balancer going through our gateway ends up like some headers get stripped out, and Spinnaker tries to redirect to an HTTP endpoint otherwise. And the other problem was if you do set up the V1 provider, Spinnaker used to be very aggressive about polling the registry, and Google would like start spitting out 429s, you're hitting the GCR too hard, and then you end up in a kind of fun situation where your deployments can't start because they're not allowed to pull the image. So you can actually change the cache interval, which makes it less aggressive and solves that problem. So all the clusters that we manage are configured using the V2 provider. So all the clusters that we actually deploy our production infrastructure is managed using the V2 provider. All our pipelines use V2. One thing that is worth mentioning is we use a special Spinnaker service account with custom RBAC roles, and that is not handled by this deployment because that varies from cluster to cluster. What do we want Spinnaker to be able to see? What namespaces do we want Spinnaker to be able to deploy into? Like we might not want the kube system namespace to be exposed to Spinnaker, for example. So that's managed separately. All of our deployment infrastructure for the different clusters that we have, they have customized Spinnaker RBAC roles. Actually, in general, they're almost all the same role, but in theory, they could all be changed. So how you deploy Spinnaker, And like another maybe noteworthy thing is we deploy Spinnaker to a cluster that's configured using a V1 provider. And the reason for that is when we originally tried to do this, the V2 provider, when we deployed Spinnaker to it, would never stabilize. We like put a little bit of effort into trying to debug it, but it just worked when we defined it as the V1 provider. I saw a Medium post maybe like a month ago where somebody said that they had to change the health check on one of the endpoints with the V2 provider for it to be healthy. So it could be as simple as that, or it might even be fixed. The other thing our deployment script does is it configures all the pub sub topics for GCR. So if you guys, maybe you're all happily using this already with the V2 provider, but unlike the V1 provider, which like polls your Docker registry to find out what's available there, the V2 provider relies on being notified there's a new image available. And so the scheme that we use for that, and I think it's a sort of recommended scheme, is we set up pub sub topics, and when there's a push to GCR, it triggers a pub sub topic and Spinnaker gets notified. I threw together a kind of stripped out version of this script, this gist. It is not pretty, but it'll show you all the how commands we do, pretty much all of them. And the other thing that I mentioned is you can see the Spinnaker pool that we're deployed to. So it's pretty small. It's just 2 nodes. Hi, mem. GCP is constantly telling us that it's underutilized, and that's despite the fact that we have what I think is a very high number of pods in our cluster. And like I said, the cluster sometimes sits at tens of thousands of vCPUs. The only caveat is originally we were using a standard node type, and then just recently we were running into a cloud driver out of memory error, and that doesn't trip the Kubernetes health check. So your Spinnaker cluster stops working, but none of the pods get restarted. So we switched to high mem, and it fixed that problem. Again, like your mileage may vary on this, is what I should say. All right, so let's talk about what GKE clusters we manage. Like really, generally, we're talking about just 2 clusters. And now I'm getting into like, what does our deployment strategy look like? So platform, our core platform is a single big GKE cluster, and it hosts the core Descartes Labs platform stack. So like all of those 12 services sit in there. All of live traffic goes to that endpoint. We do expose prod and dev endpoints. The prod is prod only in the context of this slide. Unfortunately, prod can be a couple of different namespaces. But that's where all dynamic traffic goes. I'll just sort of give you a spoiler here that we don't actually have any real customer traffic go to dev. It's just purely developers. All of our services get hit by external black box tests we wrote. We put quite a bit of effort into making these tests pretty realistic and thorough. And those tests actually inform a lot of what we do. Then we have Platform Lab, which is almost a complete replica of our platform cluster. We do have it in the same region and project. That made our lives easier, but it's probably not ideal for doing that. It could be completely isolated. Typically, like I said, no dynamic traffic. That can vary, but it's only for like special experiments that the SRE team doesn't like. The services inside that cluster are hit by an internal version of the same black box tester that hits our public cluster. We do have, like, I put that asterisk because we have a service that talks to the Kubernetes control plane, and it has the ability to spawn user models as they execute in separate clusters. But we don't have any infrastructure around deploying to those clusters. Yeah. Okay, so what are the triggers? What does our deployment workflow look like? A developer makes or maybe let's say they get a PR merged in GitHub. GitHub calls a couple of webhooks, tells Drone that there's something new to build, tells Spinnaker that there was just maybe a change to a manifest at the same time, let's say. Drone runs Bazel, builds a bunch of images, pushes them to container registry, triggers the pub sub. That tells Spinnaker, oh, there's also a new image. So it knows there's been changed to manifest, maybe a change to an image. Ideally, they'd be decoupled. It's just like the 2 possible paths, right? And then Spinnaker, like I said, it deploys to Platform Lab or Platform. Okay, so now I'm going to talk about some of the Spinnaker pipelines we have. Maybe that's the reason you're all here. I hope it's not disappointing. So these are not like full pipelines. They're most of the logic. So we have, as you can see, platform, lab, and platform, and there's this nice like annotation. It might be specific to the V2 provider, I'm not sure, that shows you the specific Kubernetes cluster you're targeting. So we have like, we'll deploy to platform lab, we'll deploy to platform tasks. Here is a random service I picked for this fun experiment. And then deploy the latest image to the dev environment. And then we have a not often used, for probably obvious reasons, deploy tasks from feature branch to platform lab. But it's there if you need it. OK, so what does deployment look like? And this is probably most interesting if you're thinking about setting up these pipelines. So this is the configuration stage. Here, this is how we define basically what we want to trigger deployments off of from our GitHub repo. So you can see here we set up that secret is obviously not real. You can see here we set up like a configuration to watch our mono repo on the master branch. And if there's a change to the deployment.yaml or the config map for platform lab, I should explain that in a minute, it'll trigger a deployment. And then over on the right-hand side, we configure expected artifacts for this stage of the pipeline. So basically we say, if you change the config map but the deployment is not in the context, then you need to go and get it, and vice versa. If you change the deployment, config map's not in the context, go and get it. Change both of them at the same time, that's fine. My screen just went white. Why did that happen? All right. OK, so, oh yeah. One thing I should mention is we try and make Platform Lab look exactly like Platform in every respect, and it almost does. There are just a couple of exceptions. And those exceptions are why, in this case, for this service, there is a custom config map for this particular environment. That's how we're differentiating like the endpoint that the service is hitting for a debugger or something like that. Ideally, there would not be a cluster-specific differentiator on the config map. OK, so that's configuration. That defines how things get kicked off. Or you could always, obviously, manually execute. And then there's no artifacts in the context, and we'll go and get both of them. Then we have the first stage, the deploy config map to in platform lab stage. And this is worth discussing because here Spinnaker behaves a bit weird. If you're like a Kubernetes manifest person and you like how that works, Spinnaker does something that makes total sense, but you might not expect. So when you deploy the config map, Spinnaker it'll get the manifest, it's in the context, and it will evaluate what the deployed config maps are already, and it will explicitly version your config map that gets deployed. And maybe you guys know all about this, but it's very important to know and understand. So it gets versioned, it gets deployed as a specific version, as you can see on the right-hand side. Maybe you could see there's like task config-v005. And if you've ever used the V1 provider, they use that same kind of versioning schema for lots of Kubernetes objects. And then what happens is the config map, the name of the config map gets bound to the deployment manifest in the next stage. So it overrides the reference to the config map with the versioned reference that it just created. And this means that your manifests are no longer a source of truth, which is one of the main reasons why I'm doing this in the first place, like using this particular provider. I very much like internally my repo reflecting exactly what's deployed, but it means that you have this great consistency in your deployments. You never end up in a situation where like your config map changes underneath your deployment, and maybe your pod has been restarted and it's picked up the new environment, or maybe it hasn't, you don't know. You never end up in that situation. It's like explicitly bound together. And it also makes the roll forward and roll back strategies very well defined, because they're again explicitly bound to each other. OK. So when you actually make a deployment of your service, it's just Kubernetes regular rolling update. You can configure this, the strategy like in your manifest, or define a pod disruption budget, and it'll deploy accordingly. And Spinnaker will sit there and wait for the deployment to roll out all the way and stabilize. And if it doesn't, Spinnaker tells you that the deployment failed, and it can execute other logic if desired, but otherwise it'll just sit here with a failed pipeline. OK, so Yeah. So on the right-hand side, in that box, you can see the YAML and the details links. The UI is a bit spotty for me. Sometimes the details button doesn't work correctly, but when you click the YAML, that's nice because you actually see the YAML with all the bound objects, be it config map, or later I'm going to talk about images getting bound, so you see the actual deployed configuration with all of the annotations that Spinnaker injects. If you click on the Details tab, it takes you to this view. And this view, again, if you're like coming from Kubernetes world, it's a little confusing because at the top of this, they have like a clusters tab where clusters are not your Kubernetes clusters. Clusters represent, I think, replica sets, and your server group represents your deployment. It takes a little while to get used to like the naming pattern. Unfortunately, this side on the left, which is showing that deployment that just rolled out, that the right-hand side reflects, that does not automatically filter. That's something I would love if there are any Spinnaker developers in the room. I would really love to see like the filtered view of the deployment on the left-hand side rather than having to find it myself. But on the right-hand side, you can see the deployment. And what you could do with that server group manager is you can undo a rollout if you want. You can just undo the rollout you just did. And you can do other stuff like scale, but we never do that. As a developer, and I guess it's worth mentioning, our developers are encouraged to modify these pipelines. Like the 3-man SRE team doesn't want to be responsible for maintaining pipelines. And that model, like developers doing the hard work, that doesn't work very well. But in theory, that's something we would like to have. The developers, they can, from this user interface, they can click on any one of these green rectangles, and from there, they populate on the right-hand side information about that specific pod. And if they scroll down to the bottom, they can view the logs for the pod. All this means is they can try and debug their service without having any GKE permissions, right? Which is nice in theory. So let's say we did our deployment. Oh, actually, yeah, so the point of this was the first part of our deployment stage deploys to this environment called Platform Lab. And I already told you we don't have any production traffic going there. There's no live traffic. At this point, what happens is the service stabilizes in Platform Lab. Spinnaker moves on to the next stage, which today is a manual validation stage. But I think in a week, it's going to be automated. I'm so excited about that. But right now, it's a manual validation stage. So here, you're presented with a view, monitor health of task deployment in Platform Lab. And if you click on that view, it takes you to the Grafana chart that you see below. The Grafana chart here reflects information that's presented from the Istio service mesh, like default set of dashboards. I should have asked, who here knows about Istio? That's great, because I've met plenty of people who have never heard of it at this conference. And to me, like, I thought everybody was excited about it. I've accidentally become this huge evangelist of Istio. I think I've convinced dozens of people to use it. But anyway, Istio is this really lovely service mesh that you know, it got really nice integration with Kubernetes. You can just have it. It takes a little work, but basically you can have it set up so that Istio sidecars get deployed with every one of your services when they come up, and all your service traffic goes through the sidecars. And all of our production services at Descartes Labs are behind Istio. All of them, all the traffic has to go through the service mesh to see our production services. So they click on this link, and here I'm a developer. I just did a deployment to Platform Lab. I've been pretty quick about clicking on that link, and I can see from this Grafana chart, and this isn't a great way to do it, like we're 2 steps away from having automation here, that, the number of non-5xx responses has just fallen off really quickly. I can see the request duration just a minute ago has spiked. I've done something pretty wrong with this deployment. And so I can stop and execute other logic here. So this is right now like the most empowerment that we provide for people to make decisions about whether or not to deploy stuff in our production environment. The conditional expression there is kind of just, I threw it in there because in the pipeline I showed you, it only triggers off of master, but you could have a pipeline like this that triggers off of other things. And here, one thing you can do to just make sure that only the merges into master get deployed to production is with some very simple spell, you can just validate what branch the commit came from. So I can say, was it from master? If it was from master, let's keep going with this pipeline. Otherwise, we're going to stop right here. We don't want to go past platform lab. Hopefully that makes sense. Okay, all right. So another deployment pipeline that I showed you here was the deploy latest image to dev. And that's a really simple pipeline, but it's quite useful, and it's kind of hard to get right. Well, it's sort of awkward. All this does is whenever there's a push to GCR for the service, it'll deploy it in a dev namespace in our production cluster. And our devs can actually hit that through the gateway. So the way you configure this is a little different to the GitHub configuration, but basically on the right-hand side, I've got the automated trigger. I'm saying, in this case, I'm using a Google Pub Sub system. The subscription name got dynamically generated as part of that script I linked to earlier. And the rest of it, like payload constraints and attribute constraints, we don't usually have to set for any reason. And then just at the bottom, so on the left, we define the expected artifact, and that says what specific image we were waiting for. And then on the bottom right, we just say, yep, that's what we need. And every time there's a push of that image, it triggers this pipeline. And this pipeline deploys to dev. Okay, actually, there is something important there. Okay, so what this pipeline does is this pipeline has a patch manifest stage, another thing that's kind of fiddly to get right. So the patch manifest stage is we're saying, you've just got a new image reference. It's in the context of this pipeline executing. We now want to find a resource that's deployed in our dev namespace in our production cluster. And here, just for like simplicity's sake, I put it as a text sort manifest source. And this is basically just patching. Okay, in fact, what happens is that USGCR Louis task is just like a handle, and that gets overridden by the bound image that's always present in the context of this executing pipeline. Does that make sense to everybody? Okay. So, oh, God, if it doesn't work, it's super hard to find out why. You get errors like that. And that's not even Spinnaker's fault. That's Kubernetes, kubectl. That's the quality of response you get. What I will say is, you can patch from the command line if you're trying to build out this patch logic and you want to make sure it does match against the deployed manifest. Do it offline. Don't do it in Spinnaker. Just do it on the CLI, iterate a bunch, and when you've got that figured out, now you're ready to actually create the Spinnaker pipeline, because it's not fun trying to debug here. Once that deployment actually happens, it's just like your regular deployment of your manifest you just did. It does a rolling deployment. You get your nice YAML and details. You click on your YAML and it shows the right image that just got deployed. Yeah. Oh, one thing that I didn't notice until preparing for this talk is the status tab always reflects the current status. Lars mentioned that's been decided that it's not a good UI feature. So if you look at a historical pipeline, you view the status, it's not going to show the status of that deployment. It's going to show the status of the latest deployment. It pulls it as you click on it effectively. Okay, so that basically is it in terms of deployment strategies. I've left off all the stuff you probably wanted to hear about, like how we could do sort of automated rollbacks to deployment. One thing that I was debating whether or not to include in this talk is, because we use Istio, because we've got virtual services, service entries, and whatnot, we have been exploring at just an experimental stage the using virtual services for canaries. And I don't know if you guys saw it, but there was a talk on that yesterday. The Istio, Spinnaker, Kubernetes V2 gluing it together. It's by the Kubler guys. But if you're interested in that, I think they have some stuff online they can point you to. Tips is really random here. It's just stuff that was painful and I felt like sharing. Yeah, if you want to work on Spell and you want to see like the automated population of fields that are accessible through Spell, you have to do it in the manual, or I can't find any other way to do it than the manual judgment configuration stage, right? This is not useful for, like usually I don't really need to evaluate stuff in this field, but what I can do is I can bring this up, explore like the population of values, go, okay, that's actually the field that I specifically wanted, and then copy and paste the spell I generated into the stage that needs it for real. One really useful thing we did by accident was made a stack driver alert that triggers when there's an update to Kubernetes deployments. And we did this just so we know, before we actually had all of the Spinnaker stuff fleshed out, so we would know when developers were making updates to services. For whatever reason, I think because of Kubernetes like patch manifest logic, this particular filter is not triggered by Spinnaker deployments, but it is generally triggered by users kubectling or using a console or something. So this is a great way to actually identify pain points for your developers. That's what it accidentally became. Like we get alerts, somebody has been deploying manually, and you can see it even tells you who did the offensive deployment. There's my name right there. And you can contact them and say, hey, what's going on? Why aren't you using Spinnaker for this? Where are we failing you? And it's been very helpful, actually. This is another random tip. How many of you guys have seen this error? All right. That error is the bane of my life. That error means that you've configured. Actually, it doesn't always mean that you could. Right, 9 out of 10 times, that means that your reference to like the URI endpoint for your default artifact in GitHub is wrong, and you can figure that out if you look at the stack driver logs or the Spinnaker logs. But otherwise, it's just like everybody knows this at Descartes Labs, right? I've seen retrofit 500. That means I messed up. I've got like the path wrong or something like that. So this is really valuable intel I'm giving you guys here. The other thing we just ran into this issue. So the cluster name at the beginning of the execution pipeline, it wasn't there up until a very recent version of Kubernetes. And when it popped up, we had all these like really long, highly verbose handles to our clusters, and the UI can deal with it, and we lost the ability to manually execute pipelines. And then we had to go through, we had to like generate new handles, and we had to go through and sort of manually change the references, which actually kind of brings me to a point I'll talk about in just a second. But first, so in conclusion, all of our Descartes Labs services have been migrated to Spinnaker, and it's great how excited the developers are. Even though, like I said, it's good to know when they've done it's actually called our ugly deployment detector. It's good to know when they've done an ugly deployment. Most of them are really happy to have this in place. The pace of the V2 Provider development has been amazing since we started. In fact, I should say, when I submitted the abstract, I had like a dozen things that were like workarounds for issues with that provider that have pretty much all been taken care of now. This does mean, though, as they add new features and as they fix bugs, deployment pipelines are constantly in flux. Every time we make a new pipeline, there's a better way to do it. And that's partly because we're learning, but it's also because the underlying provider is changing. And that does mean, because we have we're creating our pipelines manually today, that if you look at a service that's like not really hot and it's not getting deployed very frequently, it's going to have a completely different pipeline logic. Not completely, but it's going to look different to the developers, and nobody wants that. So one thing, without automation around pipeline creation, our pipelines get stale. And we had we'd had a few pushes on automated pipeline creation, but it wasn't until this conference I really learned some great ways to do that. And the other thing, very similar, but right now we're relying on our developers clicking that link, if they're lucky actually, because it's not even on all pipelines, but clicking the link, looking at the Grafana chart, and making an informed decision about whether or not we want to promote this into production. That doesn't work great. Like, I'll come in on a Monday and there's been a deployment that's just hanging there for 2 days because the developer never evaluated it. It's only sitting in our platform lab cluster. It's not the end of the world, but it's not like nice high velocity deployments. The other thing is there's like a whole world of possible deployment strategies with Spinnaker and Istio, and it's kind of overwhelming thinking about the different approaches we could take for that. I know that Lars and Ethan and co really care. They don't want us to solve this problem. They want to be able to solve it through Spinnaker features. Like they'll have like built-in strategies that leverage Istio features, and I'm excited about that. I just don't know how to like best participate in that conversation. And hopefully maybe this afternoon we can talk about it a little bit. And yet, I can't believe we're not doing this already. We all have all these great Istio metrics that are getting sunk into Prometheus. You just had a look at like one dashboard. So we really need automated analysis coming in. Seems like Kayenta is absolute no-brainer, and we just, I guess, partly because we don't have the resources, we hadn't quite appreciated that yet.